Hi everybody, this is section 11.4, second to last of all time. This is wonderful. We're getting there, we're getting there. All right, so far we've kind of had a brief introduction to logarithms. Not a great one by any means. I'm not saying that I really explained it real well, although I don't usually, even in college algebra pre-calc, just because I don't have the ability to use calculus to explain it, but it is what it is. Just think of it as another function. What's going on with that up there? Oh, there it is. I'm going to say, my goodness, that's really, there's just a 14 up there. Okay, so what we're going to do now is we're going to look at the properties of logarithms. And these only hold true for logarithms and, you know, not in any other form. So, you know, I mean, that's just like exponentials. They have certain properties, and quadratics have certain properties. Well, so do logs. Okay, so I'm going to write them down here for you, just for you, nobody else. Now, when I say properties of logs, what does that mean? That means any log, okay? Any base b. That's a common log, that's a natural log, or any other base, okay? So when I write these, I'm just going to write log. And you have to understand that this is not just for common logs, it's for all, okay? So we just make it, you know, generic. All right, so the first one is the product property, which says if I have a log, and I can put a base b in there, of two things that are multiplied, okay, that's the same as the log base b of x plus the log base b of y. Okay? Well, let's try one. Now I have to try one with either a 10 or an e in here. Okay, so let's just try log base 10 of 5 times 2 should be the same as log base 10 of 5 plus log base 10 of 2. Well, let's try it. So we have the log of 5 times 2, which is 10, obviously. I'm going to put it in exactly as I see it. And then I also have the log of 5. Now I have to, this automatically opens up a set of parentheses, so please close it, plus the log of 2. And that's got to be 1, and it is. Okay, so these have to match. Anything that I would put in there would match. Okay, so here's an example. All right, we also have a quotient property. Okay, it says the log base anything of a quotient of two things is equal to the log of that same base of x. Okay, I take the numerator and I subtract the log base b of y. Okay, so let's take an example. Let's do the ln this time because we can. So we're going to take the natural log of 27 halves. I'm just making something up. Should be the same as the natural log of 27 minus the natural log of 2. Okay, let's try it. The natural log base e of 27 divided by 2 is that echidecimal. And the natural log of 27, close parentheses, minus the natural log of 2 is the same echidecimal. Okay, so it works. And this would work for any numbers that I put in there and any base that I could possibly put in there, whether it's 10, e, or anything else. It works for a base of b. All right? I don't know if I showed you this on the calculator, but you do have an E key right here. It's very small, but it's E. Gives you the decimal equivalency. This is an irrational number like pi. Goes on forever. We usually either abbreviate it to 2.7 or 2.72. And then you have an e to the x key right here above your ln. Okay, so that would raise e to any power. Let's just take it to the 5th power. So that's really 2.71828 blah 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 raised to the 5th power. And then, yeah, it's whatever. Okay, so it's similar to pi. And e is used in, in as far as application problems, it's used in so much stuff. It's used in radioactive decay and money and Richter scales. I mean, all kinds of scientific stuff. Okay? Okay, so back to my properties. I've got the product property, I've got the quotient property, and then I have my power rule. Okay? So these are the 3 that we're going to need for this particular section. My power rule says that if I take the log base b, again, any kind of log that I want, of a to the x power, okay, you see how my exponent is way up high in the exponent spot? That is the same as x times the log base b of a. Okay? So that says that if I have an exponential way up here, it's the same as just multiplying the log by that power. So let's take an example and prove to ourselves that this is right. Again, I'm going to just try I have to do a base 10 here, or e. I'll just do 10. I'm going to take, I don't know, 5 to the 3rd power. And that should be the same as 3 times the log of 5, right? These should be the same. I have no idea if they are. If they're not, then we have a problem. Then my entire mathematical career, I better just quit then, if it's not. Down the tubes. Oh, it's the same. 2.09, 2.09. Okay? So all 3 of these properties work, and if you ever forget them, this is kind of a just a hint. I mean, obviously in this particular class, you can write things down and you can look at it. But let's just say you were in a class like at State, and they didn't let you have note cards, or they didn't let you have a cheat sheet with formulas on it, and you had to memorize all this stuff, and you couldn't remember, was this one subtraction or addition or what was it? Then just start making up problems and see if they work on this calculator. Do you see how I'm just making them up? I'm just making up numbers. So if it doesn't work, then it's not right. And if it's right, it'll work for any numbers that you choose. Okay? That's just kind of, when I studied math, I couldn't use anything, so I always relied on, gosh, if I forgot, I'd have to make something up and check it. And then I could have my rule. Okay, so we have the product, the quotient, and the power rules. All right, so write those down somewhere. Now, what we're going to do is we're going to take this entire log that's the same as, just under 1 log, and we're going to split it. Okay, I don't even want you to look at the answers on this. All right, I see that my base is 4. That's my b, right? I see that I have a quotient here. I'm in this one right here. And it tells me that I can take my numerator and subtract my denominator. So really what I should have here is log base 4 of 14 minus log base 4 of 5. These should be the same thing. Okay, now I can't check that on a calculator because I don't have a base 4 button. All right, so some of these, yeah, you're not going to be able to check them. Where's my, oh, darn it, I can't do that. Okay, well, write that down and then look. So we have log base 4 of 14 minus log base 4 of 5. It's right here. Okay, they're going to give you all kinds of scenarios. They're going to start messing with, putting the 5 first and then the 14. Well, in subtraction, the order matters, so it has to be the 14 first and then the 5. That's based on this rule. It tells you to take the numerator and subtract the denominator. All right, so they'll give you all these scenarios. So just be careful when you're choosing, especially on a test. A lot of these are multiple choice. All right, so here we have the power rule into effect, correct? All right, if we want to write it as a single log, then we want to get rid of that 1/4 power. That's way up here. That's like in the x spot, so we're going to drop it down. So this should be the same as 1/4 times log base 5 of 125. 1/4 times log, here, let me drop this down so I can see all of them. 1/4 times log base 5 of 125. Now, where is this coming from? Well, let's first of all just check to see if this piece of it's right here. And it should be. What's going on here? 1/4 log base 5 of 125. Oh, okay, there's two of them here. Or 3/4 or 125 over 4. Oh, okay, so we have to see which one is correct. Good, I like this one. All right, so we have log base 5 of 125 to the 1/4 power. Using my power rule, I'm going to drop this down in front. So I have 1/4 times log base 5 of 125. Okay, how do I get this into a number? Well, I'm going to switch it into an exponential. Log base 5 of 125 is equal to some number. As an exponent, we have 5 to the x power is equal to 125. 5 raised to some power is 125. Well, I know that 5 cubed is 125, so x has to be 3. So this whole thing right here is equivalent to 3. So we can say that this is 1/4 times 3, which is 3/4. So we do need to have that first. I thought there was only one choice. But you see how the front part is exactly the same on these two? Like obviously these two are out. So we're up here. Nice. All right, so you do have to calculate out this piece of it using section 11.3's techniques. Okay, so we've only got 11 of these. I'm thinking that they're not easy. Okay, these are all, okay, I'm not going to show you the answers. I suggest that you don't look at the answers. I suggest that you do the work and then match your answer to the choices. Okay? That's my suggestion. How many of you will follow my suggestion? I don't know. But anyway, okay. So we want to split this. Whoops. Oh, don't look, don't look. What's going on? There we go. We want to split this into its own logs, okay? So the first thing that we're going to have to do is we're going to have to get rid of that radical sign because I don't like that radical sign at all. I don't have anything that has anything with radicals in it. It's exponentials. So I know that this thing again. When's it going to go away? Never. We have 8 times, that's an s, not a 5, to the 1/2 power over y, right? That's my beginning. These are equivalent. Now this is multiplication and this is division. So I'm just going to take this right now and split that, okay? I know that I can say that multiplication, okay, hang on, I'm going way up here. Multiplication is addition, and I know division is subtraction. And I know powers can be dropped down. So I'm using all 3 of these, okay? So first of all, I changed my radical into an exponential. And now I'm going to say the log base 4 of 8. Okay, that's just this one. So I have a times there, so I'm going to say plus, because multiplication is addition, s to the 1/2, minus, because here's division, sorry, get rid of that, I forgot my log. Okay, plus log, each one gets its own log, base 4 of s to the 1/2 minus log base 4 to the y. Right? Each one has to have its own separate log. Now I'm not supposed to have any exponentials in there, so I'm going to use, first of all, I've used my radical rule to get this in there. Then I'd use my product rule to split this into 2. I'd use my quotient rule to split it again. And now I'm going to use my power rule to drop that down in front. So I have log base 4 of 8 plus, this can get dropped down in front, 1/2 log base 4 of s minus log base 4 of y. That should be one of the choices. Okay, I'm going to try to get that way down at the bottom so I can look at my choices. Hang on, let me move that up just one. This is hard. Doesn't really want to cooperate. Okay, so log base 4 of 8 minus, that's not it. Log base 4 of 8 plus 1/2 log base 4 of s plus, that's not it. I think it's D. This one's got the wrong sign there. Let's check this one. Log base 4 of 8 plus 1/2 log base 4 of s minus log base 4 of y. That one matches perfectly, doesn't it? See, they're going to start messing with you. They're going to start giving you all these different scenarios, and I think this is a lot harder to choose if you're just looking at it. I think it's much easier to do the work and then match your answer. Okay? Because if you just look at these, each one you could talk yourself into each one of these being correct, I swear. At least I could. So just ignore them. Let's try another one. Don't look. All right. Probably paused the video, didn't you? Got all the solutions. All right, we're in base 3 this time of cube root of 4 over z squared x. Yikes. Oh, man alive, what do we do with that? We're doing the same thing again. We're trying to split this up. Okay, sorry, I had to take a sip of hot. First thing that I want to do is I want to get rid of the radical. Always. Log base 3. All right. I'm using this darn rule that never goes away. So that's the same as 4 to the 1/3 power over z squared x. Okay. Now I've got division, and I've got multiplication, and I've got power. So again, I'm going to use all 3. So I'm going to be very careful about this because my product is in the denominator, which is it's a very common mistake that people make. So let's start out by saying that we have this minus, with a parenthesis because I'm subtracting all of this, okay, log base 3 of z squared plus, okay, this is multiplication, so this is going to be addition, log base 3 of x, but I'm subtracting all of it, okay, because they're both down there. All right, so now I'm going to distribute that -1 through there. Most people make this mistake by saying minus z squared plus x. It's minus minus, right? If I have a -1, these both become negatives. So just be really careful about that. Log base 3 of z squared minus log base 3 of x. Do you think they're going to give you the plus version here? Absolutely. Don't pick it. Now, oh, I'm down at the bottom already. Now I've got to get rid of these powers. Okay, so I'm going to drop those in front. We have 1/3 log base 3 of 4 minus 2 log base 3 of z. This one doesn't have one. Minus log base 3 of x. Okay. Crud. And I can't move this down anymore, can I? Let me go down right there. Okay, I'm trying to find this one. 1/3 log base 3 of 4 minus 2 plus. There's that one that you don't want to pick. Okay. 1/3 log. Okay, this sign's wrong. That should be a negative. So we'll go down to C. Check C and D. 1/3 log base 3 of 4 minus 2 log base 3 of z minus, it's looking like that one. Okay, this one's not right because it's a plus plus, so it's got to be c, minus minus. Okay, nice job. Don't pick the plus one. This is the one that's the most common mistake that I see all the time. Okay, and I think you got all that written down because I'm going to have to get a new screen here. If you don't, go back. All right, how many of these are we going to do? How many of these do we have? Yikes. How many did you assign, Simone? Okay, we've got 2 more and then we're going to go the other way. All right. Log base 3 of the square root. Maybe I won't do this one. I'll just get you started. ZS over 7. All right, I'm going to go back into chapter, I don't even remember what chapter that was, my radical chapter, right? My quotient rules. Log base 3 of ZS over 7. My product rules. Remember these things? That's why we have these things. And then the notorious radical to exponential form. Okay. Log base 3 of z to the 1/2 power s to the 1/2 power over 7 to the 1/2 power. Now I've got multiplication, which is addition, I've got division, which is subtraction, and I've got my power rule where I got to drop those in front. Okay, so it should be log base 3 of z with the 1/2 in front plus log base 3 of s with the 1/2 in front minus log base 3 of 7 with the 1/2 in front. So that's got to be one of those choices in there. Plus and minus, looks like it's that one. But I'm going to leave you alone on that one. Same thing here, right? We've got 1/3, 1/5, we've got a square. Just be careful with those. Nothing new, okay? All right, now what we're going to do is we're going to go the other way. We're going to take the double and write it as a single. So really what we're doing is we're going from, now that I have my properties lost, my log of xy is equal to log of x plus the log of y. You know, I'm over on this side and I want to go over to there. Well, here I have addition. Addition is multiplication. So it's got to be log base t of fp. This is f times p. It's not division, it's not raised, it's just not, you know, it's got to be that one. That's what the rule tells me. All right, so here, be careful because they put the log base a in here. Now this on number 11, they didn't. So, you know, don't put it back in there. Just be sure to check that you don't have it in there. Now on a test, if you would accidentally put in the log base a again, just let me know and I can fix that for you. All right, so we have 2 log base a of x minus log base a of y. All right, so the first thing that we're going to want to do is we're going to use the product or the power rule. Hang on, let me write these. Let me just write these down real quick. And log of a to the x is x times log of a. Okay. We're going to use our power rule to throw that up. That sounds terrible, doesn't it? Throw up. Here the thing is multiplied by 2, so we want to get it up here into the exponential spot. So you know how we've always been dragging it down? Well, we can also bring it up on top. Okay, so that's our first step. Now I've got subtraction. I'm over here, right? So that would be division. So we have to keep the log base a, and then it says it's you take your numerator over your denominator. I don't know if that needs to be in parentheses or not. Probably not, especially when there's a box there. So we have x squared over y. Okay, these are the same. Should we do that one? Yeah, maybe we should. Okay, so we have log base c of x minus log of c of y plus 2 log c of v. Ugh. All right, so I have subtraction, which is what? Division. I have addition, which is multiplication. And I have a number out front, so I want to bring that up top. So let's start by bringing that up top. Try to keep the order that we do things the same, so you don't have to worry about that. Okay? So this one goes up here into the power spot. Now I'm just going to work with these two. Okay? I've got division there, so that means I've got subtraction there, so that means I've got division. So I've got x over y plus log base c of v squared. Is this okay so far? I've got this divided by that. Now I've got plus, so that means it's multiplication. So I've got x over y. Boy, that just is times v squared. Okay, so this is the same as, if I want to try to clean this up just a little bit, x v squared over y. All right, so is this a, yeah, this is multiplication. This is multiple choice down here. It's not x squared v squared. The v is not underneath, so it's got to be, come on, keep going, this one, x v squared over y, base c. It's finally not answer C, it's answer D. Most of mine are always answer C. All right, so I'll do the same thing here. Okay, I'm not going to go through that one. You know, the 2 comes up, the 3 comes up, right? And then we have subtraction, which is division. And you can leave those as just solid numbers. Oh, that's what I should tell you. This would be 3 squared, which is 9. And then this one is 2 cubed, which is 8. Okay, so that's what it's going to want. It doesn't want anything. It just, you know, when you put those up top and you divide them, that's what it turns out to be. So just leave it as a fraction. All right, so this one, do you see how this one doesn't have anything? See how these other ones got the, they always get the box started for you, the log base A, and then you just fill the box in, and this one doesn't. So plus it's really different. It's got an x plus 3 and an x minus 3, but really the rules are no different. So I'll do this one for you for sure. Plus log base 10 of x minus 3. Okay, so what do I have here? I have addition. What is addition? Addition is multiplication, right? I can put those into one single log as long as the base is the same, and I can multiply them instead of adding them. Well, I've got a foiling problem again. I always have a foiling problem. Here's x squared. Let's just put parentheses around that. We have minus 3x. We have plus 3x. We have minus 9. Okay. I can simplify a little bit in there. Not much. These are gone. So I have x squared minus 9. That's all I can do, right? I can't really do much else. So here, let me just raise this up just a little bit. This is what I'm putting in there, okay? So I want to type in log with my keyboard. And then I need this 10 down here with a superscript. No, a subscript. Superscript. This is superscript, right? Super, yep, and this is sub. Okay, subscript. I want the little one on the bottom, so I'm going to fill in a 10 there. And then I want x with a superscript, 2 minus 9. Okay? That's the same as that. Let's see. That's what it wants. Okay? So that's the properties of logarithms. And we will use our properties and our exponential logarithmic forms to solve next, and then we'll be done. So I will see you for the last section.